All right, here we got the notes for solving square roots, or quadratics with square roots. So it's possible to find the roots of a quadratic equation. So remember, roots and zeros and x-intercepts are all the same things by taking the square root in certain circumstances. So typically you want to have the x with being squared or the quantity with the x being squared. If there's any regular x's floating around, it does not work. So the first thing, you need to isolate the squared quantity, whether that's a set of parentheses with the squared outside, or it's an x squared term. You need to get that by itself. Once you do that, we take the square root to get rid of the squared exponent here. Now you have to be careful because when you take a square root, there's actually two solutions. The square root of 4 is both 2 and negative 2, because 2 times 2 is 4, but so is negative 2 times negative 2. So they are both the square root of 4. And then you'll have two equations to solve, one with the positive, one with the negative. So just our general strategy, isolate the term or the quantity with the squared exponent. Take the square root and split the equation in two, one for the positive root, like 2 up here, one for the negative root, like negative 2. And then you continue to solve them each equation separately. So if we look at this one, we want to get that negative 2x squared by itself first. So to do that, I have to bring the 14 across. So negative 2x squared equals negative 15. Divide both sides by negative 2. So x squared is equal to, well, it's going to be 7.5, or 15 over 12. So then I'd go to take the square root. So x equals, let's see what that's going to be. Square root of 7.5 is about 2.74. But I also get the negative, so I get x equals negative 2.74. And now I'm done, because after I take the square root, the x is by itself. Like there's no more steps left. In that case, the square root was the last step. Okay, so let's look at number 2 here. So my first thing is I need to bring the 34 across. So 3x minus 8 squared is 27. Now I cannot distribute that 3 because of the squared. So the next step would be to divide that 3 across, because it's 3 times the parentheses. So to get rid of it, I would have to divide. So give me that. So now the thing that has the squared is by itself, so square root on both sides. So this is where the equation is going to split. The square root of 9 is 3, but it could also be negative 3. Add 8, so 11 is a possibility, or 5. So 2 possible solutions. Okay, so for 3, kind of similar pattern, add the 27 across. So that's going to give me 4. Cannot distribute the 4, so I have to divide it out. So now the thing that's squared is by itself, so I can take the square root. Now when I do that, once again, 2 solutions. The square root of 1 is 1, but it could also be negative 1. So add the 6 across gives me 7. Add the 6 across gives me 5. So 2 possibilities. Okay, so 4 here is kind of like the first one. So move your regular numbers first. So negative 3x squared equals negative 27. Subtract the 19 across. Divide by the negative 3. So x squared is 9. Now the squared thing is by itself, so square root both sides. So I get 2 possible answers, 3 and negative 3. And there's no addition or subtraction like there were here, because once I take the square root, the x is in fact by itself. All right, number 5. So bring the 42 across. So 4, 2x plus 4 squared equals 4. Cannot distribute because of the parentheses with the squared, so I have to divide 1. Take the square root of both sides. So 2x plus 4 could be positive 1. 2x plus 4 could be negative 1. So bring the 4 across. So 2x equals negative 3. 2x equals negative 5. Divide by 2. So if you want the fraction, negative 3 halves. If you want the decimal, negative 1.5. Over here, if you want the fraction, negative 5 halves. If you want the decimal, negative 2.5. Okay, 6. So let's see here. We can subtract the 14 across. So 25x squared minus 5 equals negative 4. Okay, let's see here. So the next step would be to divide both sides. So you could, if you wanted to, distribute the 25 through, because that squared is not outside the parentheses. But I prefer to solve them all the same way. So I'm going to actually divide by 25 right now and keep it similar to how we did this one up here. Keep the steps in the same order. Oops. So once I do that, in this case though, the parentheses are gone. So we have to add 5 to both sides. So let me grab my calculator and work out what -4 over 25 plus 5 is. So that is 121 over 25. You want to keep it in a fraction. You don't want the decimal because when you take the square root, it's going to be easier to look at if you take the square root of a fraction as opposed to a decimal. So square root both sides. Now, when you square root a fraction, you just do the top and bottom separately. So the square root of 121 is 11. The square root of 25 is 5. But I also get the negative solution as well. And that's done because after I take the square root, there's nothing left with the x over here. All right, 7 is back to like the ones we've done. So add the 28 across. So 16, 5x minus 3 squared equals, what's that's going to be? 9. Divide everybody by 16. So 5x minus 3 squared equals 9 over 16. So once again, leave it as a fraction. Don't make it the decimal. It'll be harder for you to do. So now in this case, I square root now because the square root's outside the parentheses. So 5x minus 3 is equal to 3/4, square root the top, square root the bottom separately, or 5x minus 3 is equal to -3/4. So add the 3 across. So 5x is equal to, so 3/4 plus 3, you want an improper fraction, you don't want a mixed number, so not 3 3/4. That is 15/4. Over here, -3/4 plus 3 would be 9/4. The last step, divide by 5. Now, when you divide a fraction by a whole number, what actually ends up happening is that whole number multiplies with the number on the bottom. So this would be 15 over 20, which will reduce. You can take a 5 out of both of them, 3/4. Over here, we would have 9 over 20, which does not reduce. So there's no common terms between 9 and 20. So those 3/4 and 9/20 would be my solutions. And that is the end of the section.